odds of accidental life seems extremely remote. Dr. Robert Piccioni has a Ph.D. from Stanford and was formerly on the research faculty of Harvard, as a Bachelor of Science from Caltech, where he studied under famous physicist Richard Feynman, an expert on cosmology and Einstein's theories. Dr. Piccioni is developing a new TV series, Einstein for Everyone, and is the author of 2 books, Can Life Merely Be an Accident? And Everybody's Guide to Atoms. And would like to also add a special 25% discount on both books if, when you order, you mention Michael Vera or Blog Talk Radio. So everybody, please welcome Robert Piccioni.
Hi, Michael.
Good evening, sir. Hi, and how are you this evening?
I'm great, Michael. Thank you for having me.
Oh, thank you so much for coming on, and in such short notice, too. I really do appreciate that. I thought you'd be a really good fit for tonight and for this show, and I hope that we have you on a lot more in the future as well.
Well, I look forward to that, and it's an honor to start off the new year with you.
Well, thank you, and it's an honor for us to start off with you as well. So I guess we could start out with you telling everybody a little bit about yourself and how did you become a physicist?
Well, Michael, I was born a physicist. I really didn't have any option about it. My dad was a high-energy physicist, and when I was growing up, all he would talk about was physics. And I thought everybody in the world was a physicist. And it wasn't until I went to school that I realized that some people's dads were, firefighters or policemen or teachers or lawyers and so forth. And when I went to school, I knew everything about antimatter, but I had to have the other kids explain to me what a shortstop was.
Well, that's not such a bad thing.
Yeah, so, I've been having physics in my blood since I was born, and I even cut my teeth, literally, on the physics books of Enrico Fermi, who's one of the most famous physicists of the 20th century and was my dad's mentor. So one night we were invited to their house for dinner, and I was just a toddler. They let me loose, and I ended up chewing on his books. That was quite a scene. But he was a gracious guy, and he said a few nasty things in Italian that I won't repeat, and then he said, well, at least he has good taste.
Well, I love sports, but I think I love stars and planets and just knowledge of the universe much more than I love anything. It's just fascinating, and there's so much about it that we don't know, and so much about it that I'm looking forward to you telling us about tonight.
Yeah.
So what is high-energy physics, and what does it have to do with life?
Well, one of the greatest discoveries of science over the centuries has been that everything in the universe really is intimately connected. And philosophers have thought that also, but science has really proven that that's true. And even the things that are vast, like galaxies, are connected to atoms. And so high-energy physics is the study of the very smallest stuff, the little particles that make up the atoms that make up everything that we see around us, from galaxies to butterflies. So high-energy physicists study these little pieces of nature and the forces between them, and when we understand that, then we understand why a star does what it does, why a star provides life to us here on Earth, why galaxies are the way they are, and indeed why the universe is the way that it is. So it's the study of the most fundamental of the smallest things of nature.
That's incredible. Now, why did you write this book?
Well, I have a mission, and that is to provide public access to science. I'm on a mission to share the exciting and important discoveries of science with the public, because I think that many of the issues that are very important in facing our society today, like energy and the climate and the health, the environment, and even the economy, have critical scientific issues associated with them. And it's not my job as a scientist to tell people what they ought to believe. I mean, I'm not here to promote my political agenda or my religious beliefs or anything else. But I think that if I can, you know, communicate to people what has been discovered in science, then everybody will then be capable of making up their own mind, and they'll feel more comfortable making those decisions, knowing that what they know about science, and I think they'll be happier with the results. So, you know, I like to say, Michael, that you don't need to be a great musician to appreciate great music. I mean, I like all kinds of music, but I can't play a note. And I think
you and me both.
I think the same thing is true for science. Even if you fear physics and are allergic to math, you can still appreciate the great discoveries, you know, what we've learned about the universe, what we've learned about atoms, what we've learned about life, and you can appreciate the intriguing mysteries that remain that we haven't discovered, because our universe is just fascinating. I mean, it's more fascinating than the most creative science fiction. There is nothing that I know of that's more exotic and more surprising and really more glorious than the universe and all the things that are around us. So I just want to let that out. You know, I've worked all my life doing things like this, and now that I'm sort of retired, still working 7 days a week, you know, I feel a mission to let this stuff out.
Great. And what do you mean by merely an accident?
Well, you know, Michael, for 50 years at least, most scientists have believed that life started, you know, the first life originated because the right kind of molecules banged into other molecules in just the right way, and voila, there popped out the essence of life, which would be DNA, or maybe its simpler cousin, RNA. And then after that, that divided and, you know, made more life and mutated and then new species and all that stuff. But the real issue that I wanted to address was, how did that first living thing come into existence? So as I said, you know, there was a great experiment done in 1950s that showed that nature could all on its own make amino acids, which are an important part of life. And then, since then, you know, chemists have found ways that nature can make nucleotides and proteins from these amino acids and so forth and so forth. But the real issue is, how do you get all that stuff together and create a piece of DNA? And DNA is the most fantastic thing in the universe. There is nothing in the universe that's nearly as complex, nothing that has a more sophisticated design, nothing that is more intricate and complicated than the DNA that all of us have in our bodies. A galaxy is nothing compared to your DNA. In every cell, you got 10 trillion cells in your body, and in every one of those cells, you have a complete set of human DNA, which not just defines who you are, but it's the blueprints for building Michael Barra, right? I mean, you started from one cell, and your DNA figured out how to build the whole rest of you. So it's not just the blueprints; it's the instruction manual, and that's in every one of your body cells. You have a complete set. And
so it would be fair to say that each cell really has its own intelligence.
Yeah, I mean, the intelligence is all programmed in there, in your DNA, yeah. And,
that's amazing.
And every one of those sets of DNA and every one of those cells in your body has 100 billion atoms in it. That's how big it is. It's amazingly complicated, and it's this enormous structure. 100 billion atoms. That's as many stars as there are in a major galaxy. But the key difference is, if you had this great galaxy swirling around like you see in some of these spectacular Hubble Space Telescope images of everything swirling around, if you switched 10% of the stars with the other 10% of the stars, you know, the galaxy wouldn't even notice. I mean, it would just keep swirling around and everything would be hunky-dory. But you start moving atoms in human DNA, and you know, pretty soon the organism is dead. those atoms, how finely tuned our universe is to satisfy all those requirements. And I broke them down into 4 different groups. You need to have a universe which allows life to exist. Ours obviously does. You need to have the right atoms that life is made of. You really need carbon and oxygen, for instance. You need to have a viable habitat like the Earth, or some other planet or some other place where life is going to live. And finally, you need to have this DNA. You need to have some sort of an effective genetic code that is the instruction manual for life. Now, perhaps all of this started in some sense, at least in a physics sense, with Albert Einstein, because he said toward the end of his life that what had really interested him in his life was trying to find out whether God had any choices when he made the universe. Einstein was a deeply religious person. He didn't necessarily belong to any of the normal religious groups, but he did certainly believe in God. And so he wanted to know whether any universe had to be pretty much the way ours is, or whether it could have been vastly different. And then if he had discovered that it could have been different, he would have tried to figure out why God chose this particular way to make the universe. So that was one of the great fascinations of his life. And, during his life, he didn't get the answers. But here we are 50 years later after he died, and we know a lot more now, and science has discovered that there's actually about 20 knobs. And what I mean by a knob is there are 20 of these variables which could be adjusted over a wide range, like the strength of gravity. It could be almost anything. But it turns out that if you turn the knobs to any other values than the ones that are in our universe, then you get a universe that can't support life. So I'll give you an example. One of these knobs is the mass of the proton. Now, everything we see is made of atoms, and the core of every atom is protons. It turns out that if the proton's mass was 0.25% more, there wouldn't be any atoms in the universe. No atoms, no galaxies, no stars, no us. And if the proton's mass was 0.25% less, then stars would produce almost no energy at all. And so, we wouldn't exist because our life depends on the energy from the sun. So unless the proton's mass is pretty much exactly what it is in our universe, a different universe with a different setting of that knob would have no life in it whatsoever. There wouldn't be protons, there wouldn't be atoms, and there wouldn't be a possibility of making life. So there are 20 of these things. And some of them are extremely demanding. I mean, the proton mass could change by 0.25%, but right after the Big Bang, the universe had a certain expansion rate, and that expansion rate had to be the right number to a phenomenal precision for the universe to exist today. So if the expansion rate had been a little bit more, the universe would have expanded so rapidly that it would be now empty. It would only be like one atom where a galaxy is today, so you couldn't have any life. If the expansion rate had been a little less, then the universe would have collapsed, and everything we see would be scrunched down to one point, and there wouldn't be any life then either. And how precisely does that expansion rate have to be? Well, in Einstein's theory of general relativity, this curvature of space-time that determines the expansion rate could be any number from, let's say -1 to +1. So let's imagine that you had yourself a ruler, and on one side it said -1, on the other side it said +1.
Okay.
And only right at the little piece near 0 is life possible. So now stretch this ruler. Stretch it across the entire Earth. Stretch it across the entire galaxy. And stretch it across the entire observable universe. I mean, that's as big as it could be, right? Across the entire universe. The little area near zero where life could exist is still smaller than a single atom.
Wow. So what makes our universe so special then? How come life here, and do we know for sure? I mean, what are the probabilities of life being elsewhere in the universe? I know you just pretty much spoke it out with the ruler thing, but I mean, have we discovered planets that possibly could have life?
Well, we've discovered about 400 planets that are outside of our own solar system, but none of them at this point is even remotely close to an Earth-like planet. In part, that's because the way that we detect these things works real well if the planet is huge. So we find lots of huge planets, planets that are bigger than Jupiter, typically. And it's hard to find, with our instruments today, it's hard to find small planets like the Earth. So that's part of the reason. But I think that Earth is really a very, very special planet. I mean, it's not just the best out of the 8 planets in the solar system. 8 now that Pluto has been demoted.
I don't know if I totally agree with that, but
well,
it's always been a planet.
I grew up with 9 planets, and I'm having a little trouble with that one too.
Yeah.
But I think the Earth is probably, I think you'd have to find 1 billion planets before you found one that was as good as the Earth. If you list all, and I do have a list in my book of all the things that make the Earth special, and there's about 13 of them that are really remarkable. The Earth has a magnetic field that's 100 times larger than the other terrestrial planets. That magnetic field protects our atmosphere from the solar wind, which would otherwise just sandblast the atmosphere away. There's 1 billion tons of charged particles coming out of the sun every second. And without a magnetic field, we wouldn't have an atmosphere. So, we're just darn lucky to have an atmosphere that's so immensely large and unusual for a rocky planet.
Now, it could be possible, couldn't it, that there'd be planets that harbor maybe life that we don't yet understand, that maybe could live in those environments?
It could be possible for there to be, I go through this analysis and I show how remarkably improbable it is that life could arise by accident, but obviously it did. And so there has to be some mechanism that creates life, which science hasn't yet discovered. And there's no reason to think that that mechanism doesn't work throughout the entire universe. I mean, our neck of the woods isn't much different than the rest of the universe. So if life exists here, as obviously we know it does, then there's a good chance that life exists in other places in the universe. We haven't found it yet. And I think we're going to have to look a very long distance from Earth to find one, a planet that could have life. But, I'm sure that it must be out there somewhere. If we're here, there's got to be other places where life started too.
Well, there's a lot of people who claim to have seen UFOs and things of that nature, and I would think that if they are out there and they have been to this planet, then they must be way far advanced than we are to be able to get to us and us not even know where they came from. So I've been finding this stuff fascinating since I was a little kid, and I've always hoped that I'd live to see the day when they do discover life on another planet. I think that would be fascinating.
Oh, that would be one of the most important days in our history, to find life anywhere other than the Earth. Yeah, absolutely. That would be fascinating, and it'd be fascinating to find out what they're like and whether they're made the same way we are, whether they think the same way we do. if they've been here, then, as you say, they've got to be more technologically advanced than we are, because we're not yet a spacefaring race.
Right, right. And that leads me to what I was just going to ask you is, what is special about the atoms we are made of?
Well, the atoms we're made of are the rarest and most precious ingredients in the entire universe. And they took billions of years for these atoms to be created. Because in the beginning, when the universe was, let's say, a couple minutes old, the only atoms that existed were hydrogen, helium, and just a dash of lithium. I mean, a minute amount of lithium and nothing else. So there wasn't a single atom of carbon in the entire universe. There wasn't a single atom of oxygen or iron or phosphorus or any of these other elements without which our life couldn't exist.
Mm-hmm.
And if you just have hydrogen and helium, I mean, those are both gases. Helium doesn't react with anything. It's a noble gas. Hydrogen can only make, you can have one hydrogen, you can have two hydrogens together, and that's it. So you really can't make anything out of hydrogen and helium. So if that was all there was, there couldn't be life. So where did all these atoms come from that we're made of, and in fact that the Earth is made of, because the Earth isn't made of hydrogen or helium either? Well, they all came from stars. 90% of your body mass and 100% of the Earth's body mass, almost 100%, all of those atoms were made in the center of some giant, super hot star through the process of nuclear fusion. So this hydrogen and helium gas had to be sucked into a star, and then it had to be converted by nuclear fusion in the center of a star into carbon, and then into oxygen, and then into other elements. And then when the star died and it exploded, all of those wonderful elements got spread throughout the galaxy. The star explodes, it's a supernova, there's a blast wave going off into space, and it carries most of the star with it in great clouds. And these clouds are immense. I mean, they can be 1,000,000 times larger than our solar system. And
wow.
by enriching these clouds with hydrogen, with carbon and oxygen, one day those clouds start to collapse, and they make new stars and new planets and new solar systems. And those planets now have carbon and oxygen on them. So that's where the Earth came from, and that's ultimately where we came from. So our atoms were once in the center of a giant hot star at a temperature of hundreds of millions of degrees. And when the star exploded, the temperature might have been billions of degrees. And now those atoms are in our body. So it's this, it's a beautiful recycling system, if you will. Or, nature builds from the smallest things up to the larger things. And all that process took billions of years, and finally we're here.
And it's amazing how it seems like so much intelligence is behind it when you think about how, everything serves a purpose for everything else that's living on this planet. Mm-hmm. Pretty much everything. I don't know what the use of a mosquito would be, except for a regular annoyance. But I mean, with everything else, it's just amazing how that can happen. And I mean, I just believe strongly that there's some intelligence out in the universe. What it is, I don't know. But so I guess our Earth and our DNA would be very, very special and unique then.
Yeah, absolutely, absolutely. And another remarkable thing that happened, and actually, when I got my PhD, part of the task was to measure this peculiar characteristic of nature. And that is the difference between matter and antimatter. Mm-hmm. So when the universe began, it was equal amounts of matter and antimatter. But today there's almost no antimatter around. I mean, science has never discovered any concentration of antimatter anywhere in the universe, and it would be pretty visible because it makes an enormous blast when it meets regular matter. So it turns out that although three of the forces of nature treat matter and antimatter exactly the same, and so they would preserve equal amounts of antimatter and regular matter, the fourth force, which is called the weak nuclear force, has a very slight preference for matter. Very slight, like 1/3 of a percent. So my thesis was to measure that number. Well, anyway, when the universe began, because of that slight preference, there was a little bit extra matter when the universe got to be 1 second old than the antimatter. And just a teeny bit. And how much? It was for every 1 billion anti-electrons, there were 1,000,001,000 electrons.
Wow.
And then they annihilated, and the billions wiped each other out, converted into energy, and the 1 electron was left. And similarly, there was 1 proton left out of the billion. And everything that we see around us, all the stars and all the galaxies and everything that we see, is made of those 1 in a billion survivors. Now, if that number, 1 in a billion, had been a little less, we wouldn't exist. And if it had been a little more, the universe would have collapsed and we wouldn't exist either. So the odds of all of these things working out to give us the atoms that are in our body today are about the same as if you had 11 decks of cards in front of you and they were all shuffled, the regular playing cards with 52 cards.
Mm-hmm.
Imagine that you drew 1 card from each of the 11 decks. And how likely would it be that they all turn out to be the ace of spades?
That'd be very unlikely, I think.
Yeah. Well, that's the same probability as one of the particles that started out at the Big Bang ending up on a habitable planet being the right kind of atom to make life. It's really long odds. Of course, there were a lot of particles to begin with, so, there are enough atoms to make life out of. But if that number had changed a little bit, we wouldn't be here. So there are all these little things about the universe that, science has discovered over the years, and they're really remarkable. And I think they're fun. I mean, all of this, to me, is even more exotic than science fiction.
It is fascinating. It's very fascinating. And what about Mars? Do you suppose that at some point maybe the planets were aligned differently at one time and that Mars might have at one time been habitable? I know I'm going outside the box a little bit now, but I've heard different stories about that. I've always wondered.
I don't think there's definitive evidence on that. I think it's still an open issue to some extent. It certainly looks like there was water or maybe some other liquid on the surface at one point, because you see erosion patterns that sure look like erosion patterns that we see on Earth from water, from rivers.
Right.
And some of these are enormous. I mean, there are gullies on Mars that are deeper than the Grand Canyon. So something had to happen in a big way. Now, Mars also has the biggest volcano in the entire solar system. It's, I don't know what it is, 3 or 4 or 5 times bigger than Mount Everest. I mean, it's immense. And so the possibility is that there was ice maybe below the surface, and the volcano erupted and melted some vast amount of the surface, and that created, for a very brief time, a flow of water. That's a possibility. And as we explore Mars more, we'll probably learn more, and maybe one day we'll figure out whether these water erosion marks are due to the fact that there was water for just an instant, or maybe 1,000 years, a short period of time, or whether water existed there for hundreds of thousands or millions of years.
Now, I understand that there's actually oceans on the moon of Jupiter, Europa, one of the moons anyways. Is that true?
It's believed that that's true. No one has proven that there's actually water there, but all the signs are there. NASA would dearly love to be able to put up a satellite with a big drill that would drill down through the ice. The surface of Europa is completely covered with ice. So if we'd like to drill down through that ice and see if there's an ocean underneath, the ocean would be the water would be liquid underneath the ice cap because there's heat coming from the center of the planet. And that heat comes from the fact that Jupiter is flexing the planet back and forth like a donut, a rubber band, because of the force of gravity. So the planet is being, squeezed and stretched and squeezed and stretched, and that friction causes a lot of heat, and so it's perceived that the water could be in liquid form underneath the ice cap, and possibly there could be life there. I mean, the water would be extremely cold, but there is water underneath the ice caps on Earth, so maybe there is life underneath the ice caps on Earth, so maybe that's true on Mars too, on Europa also.
Well, you just answered my next question, because I was going to ask what that would mean to mankind to find out that there was an ocean under there, and that, I was going to say that I would think it'd be possible for some life to be sustained. Sure.
We can also get along if we choose to. I mean, it's sort of like going to see your in-laws at Thanksgiving dinner, right? You can get along or not, depending on how things go. So, but I think that there's no inherent conflict between science and religion, in spite of the fact that there's some scientists who seem to be on a campaign to cause as much trouble as possible in that regard, and there's some religious people who are very concerned that science is an attack on their faith and so forth. But, I think that they're both sincere and earnest efforts to search for truth. And truth is something that all of us should value. And none of us gets to decide what the truth is going to be. That's not within the capability of human beings. Nature or God or whoever has set up the truth, and, if we're lucky, we get to discover it. And as a scientist, truth is my main objective, and any way that you get there is great. So if you have a question that can be asked with a number, then you probably want to go to a scientist, because science is really good with numbers. But some of the really big questions of life, like, what's the purpose of human existence, or what's the right sort of moral code for a person to live by, and what is the meaning of life itself? I mean, these are questions that science can't possibly answer. I mean, they're just not within the purview of science. So I think there's, intellectual room for science, and there's intellectual room for faith, and we should work hard to find a common ground between us.
I agree. And, there are so many questions, and I don't know if we'll ever get all the answers, by no means. But nevertheless, I'm glad that there's people such as yourself who get out there and get the answers for us, because, again, this is a very fascinating subject, and something I definitely wanted to get to cover here on the show, and I was very glad that you were a part of it. And if you'd like, you can give out your website and tell everybody how they can get the book. We're not cutting out yet. We still have some time, but some might be wondering and waiting. So.
Sure. Well, thank you, Michael. I have a website. I also have a radio show, and you can find out more about me and my books and my radio show by going to the website, which is guidetothecosmos.com. guidetothecosmos.com. And I also have a toll-free number that the listeners could call and find out about buying a book or or I have two books, so we're offering a special discount to the listeners of Late Night in the Midlands. So the book, Can Life Be Merely an Accident, is available to your listeners at a 25% discount. And my other book, Everyone's Guide to Atoms, Einstein, and the Universe, is a hardcover book, so it's in lots of color pictures. Actually, they both have lots of color pictures. And that's available also. And you can't buy them anywhere else for a better price than from me directly, because then we don't have to pay the retailer, right?
Right. And thank you so much for giving that special discount to the listeners. So I hope they all take up on it, because I know that I'm definitely going to be reading these books.
Oh, great. Thank you. Anyway, so the toll-free number is area code 877-COSMOS-2. That's 877-COSMOS-2.
Okay, great.
Now, they need to mention Michael Vara or Late Night in the Midlands to get the discount, because otherwise I can't compete with my distributors like Amazon if I accept with a special radio offer.
Right. Okay, well, thank you very much. I'm sure the listeners appreciate that, and I'm sure they will be logging onto your website for sure. Can you talk a little bit about this new TV series that you're working on, Einstein for Everyone?
Sure. I gave a class at the local California State University. It was a class it's an adult education program. So I don't, I'm retired, and I don't give classes where I have to argue with students about why they didn't get an A- instead of a B+. Been there, done that. That's enough of that. So, so I just teach where there's no test, there's no homework, and everything's just for fun. So I gave a class that was called Einstein for Everyone, and it was 8 sessions of 2 hours each, and I explained all of Einstein's theories to a bunch of poets. Now, poet is what a physicist calls anyone who's not a physicist. So I explained Einstein to people who, most of them had never studied physics. Most of them really didn't like math, and all the course was with slides and pictures and discussion, and there was they didn't have to memorize any equations, and they didn't have to do any problems. I showed important equations like E equals mc squared, because if you're going to talk about Einstein, you have to look at that equation. But I didn't make anybody solve it. What I did do is I explained it in English, and people had a great time. I mean, they really enjoyed it.
Well, that's my kind of class.
Yeah. And the response was so favorable. In fact, the student ratings for that class were the highest in the history of the university.
Awesome.
So I approached one of these DirecTV channels and suggested to them that they ought to carry it. I mean, in fact, I approached Jewish Life Television, which, at least in our area, is Channel 366. And I told them, look, you got to run this thing on Einstein, because after all, he was the most famous Jew in history after Moses. And
right.
they didn't really like that. They came back and they said, well, what about Sandy Koufax? But anyway, he certainly was an important person, and a very interesting person. I mean, not just his science, but I mean, he was a real character. Most people don't realize that his life was basically a train wreck for the first 30 years. I mean, he practically starved to death. Nothing worked for this guy, and the greatest thing about Einstein is not that, I mean, obviously he was smart, but the greatest thing about him was he never gave up. I mean, he was rejected thousands of times, and he never gave up. He just kept fighting, and eventually he became a world celebrity. I mean, it's really sort of a great story. Anyway, so I tell the story of his life, and I explain his theories, and We talk about E equals MC squared and how we can use that knowledge to better the way that society generates energy and solve our global warming and our energy crisis and stop sending $400 billion a year to the King of Saudi Arabia and all that stuff.
Yeah, it'd be nice if they start listening now.
Yeah.
Believe me, I preach about it quite a bit on this show, and I try not to be too political, but sometimes I just can't help it.
Well, Einstein had a good sense of humor, too, and he's quoted as saying that the difference between stupidity and genius is that stupidity has its limits. I'm sorry, I said it wrong. I said it backwards. He said, genius has its limits. Stupidity has no limits. How did I miss that?
That's true. That is so true.
Yeah.
Yeah, I know every morning when I'm on my way to work. That's proven on the highway. So when is this series supposed to start?
Well, we're hoping to do a pilot in sometime in March, and like everything else, it's all about money. So the network is looking for a sponsor.
Okay.
So we'll do the pilot in March, and if it's good and we can get a sponsor, then they'll put us on. I guess it may be 6 or 12 months after that. I've never done any TV, so I don't really know what the lead times are.
Well, good things come to those who wait.
Yeah, those who never give up, right?
Yeah, I look forward to it. I hope it does make it, and because I would definitely like to keep that on my TV listings. So, once again, you give your website one more time, because we're getting about to the end of the hour now.
Okay. The website is guidetothecosmos.com, and the toll-free number is 877-COSMOS-2. That's 877-COSMOS-2.
Okay, great. I want to thank you so much for being a guest on the show tonight, and I definitely would like to get you back on in the near future because I think that your knowledge is very fascinating, and I know plenty of people were very interested in tuning into the show tonight to listen to you.
Well, that's
so
very kind of you,
it.
Michael, and I really appreciated being on your show, and you asked great questions, and we talked about exciting things, so I'd love to come back.
Okay, great. Before you go, would you mind if I took one call?
Sure.
Somebody's calling and wants to ask a question, so make it good. 803 area code, you are on Late Night in the Midlands.
Hello, am I on Late Night in the Midlands?
You sure are.
Hey, I just wanted to comment. I don't really have a question. I just wanted to comment on your guest. I checked out your website, Mr. How do I pronounce your last name again?
Piccioni.
Piccioni.
Why don't you call me Robert? It's easier.
Robert. Bobby's even easier.
No, my wife calls me Bob when she's angry, so don't do that.
Okay, I won't do that. But I checked out your website earlier today after I seen you were on Mr. Vera's schedule, and I just have to comment. I seen a picture of you, and I don't know if it was your daughter or your granddaughter, and underneath it said, "You're never too young or too old to ask why."
Yeah, that's my granddaughter.
That's your granddaughter? I just thought that was a perfect comment and a perfect quote, and I loved it. I just want to hear your opinion on it, and I'm going to hang up now and listen to your comments.
She never stops asking why. It's her that thought of it. Yeah. Well, that's what life is about, Nothing better than
that's
grandkids.
Great.
Yeah.
All right, Billy, thank you for calling. He's not with us now, but he's still listening.
Okay, well, thanks for pointing that out, and I'll tell my granddaughter you liked it.
Okay, and once again, Dr. Robert Piccioni, I want to thank you so much again, for being a guest on Late Night in the Midlands, and I will definitely keep in touch.
Okay, great, Michael.
Oh, and by the way, I will have a link on my website, so if anyone goes to my website, they'll be able to get over to yours and get a hold of that book as well.
Okay, great.
Okay?
And my best wishes to all of the listeners.
All right, thank you so much, and our best wishes to you, and you have a great night.
You too, sir. Thank you very
All
much.
right. Thank
And you can appreciate the intriguing mysteries that remain that we haven't discovered, because our universe is just fascinating. I mean, it's more fascinating than the most creative science fiction. There is nothing that I know of that's more exotic and more surprising and really more glorious than the universe and all the things that are around us. So
I agree.
I just want to let that out. You know, I've worked all my life doing things like this, and now that I'm sort of retired, still working 7 days a week, you know, I feel a mission to let this stuff out.
Great. And what do you mean by merely an accident?
Well, you know, Michael, for 50 years at least, most scientists have believed that life started, you know, the first life originated because the right kind of molecules banged into other molecules in just the right way, and voila, there popped out the essence of life, which would be DNA, or maybe its simpler cousin, RNA. And then after that, that divided and, you know, made more life and mutated and then new species and all that stuff. But the real issue that I wanted to address was, how did that first living thing come into existence? So, as I said, you know, there was a great experiment done in 1950s that showed that.
Well, you know, I love sports, but I think I love stars and planets and just knowledge of the universe much more than I love anything. It's just fascinating, and there's so much about it that we don't know, and so much about it that I'm looking forward to you telling us about tonight.
Yeah.
So what is high-energy physics, and what does it have to do with life?
Well, you know, one of the greatest discoveries of science over the centuries has been that everything in the universe really is intimately connected. And philosophers have thought that also, but, you know, science has really proven that that's true. And even the things that are vast, like galaxies, are connected to atoms. And so high-energy physics is the study of the very smallest stuff, the little particles that make up the atoms that make up everything that we see around us, from galaxies to butterflies. So high-energy physicists study these little pieces of nature and the forces between them, and when we understand that, then we understand why a star does what it does, why a star provides life to us here on Earth, why galaxies are the way they are, and indeed why the universe is the way that it is. So it's the study of the most fundamental of the smallest things of nature.
That's incredible. Now, why did you write this book?
Well, I have a mission, and that is to provide public access to science. I'm on a mission to share the exciting and important discoveries of science with the public, because I think that many of the issues that are very important in facing our society today, like energy and the climate and the health, the environment, and even the economy, have critical scientific issues associated with them. And it's not my job as a scientist to tell people what they ought to believe. I mean, I'm not here to promote my political agenda or my religious beliefs or anything else. But I think that if I can, you know, communicate to people what has been discovered in science, then everybody will then be capable of making up their own mind, and they'll feel more comfortable making those decisions, knowing that what they know about science, and I think they'll be happier with the results. So, you know, I like to say, Michael, that you don't need to be a great musician to appreciate great music. I mean, I like all kinds of music, but I can't play a note. And I think
you and me both.
I think the same thing is true for science. Even if you fear physics and are allergic to math, you can still appreciate the great discoveries, you know, what we've learned about the universe, what we've learned about atoms, what we've learned about life. Look forward to that, and it's an honor to start off the new year with you.
Well, thank you, and it's an honor for us to start off with you as well. So I guess we could start out with you telling everybody a little bit about yourself and how did you become a physicist?
Well, Michael, you know, I was born a physicist. I really didn't have any option about it. My dad was a high-energy physicist, and when I was growing up, all he would talk about was physics. And I thought everybody in the world was a physicist. And it wasn't until I went to school that I realized that some people's dads were, you know, firefighters or policemen or teachers or lawyers and so forth. And when I went to school, I knew everything about antimatter, but I had to have the other kids explain to me what a shortstop was.
Well, that's not such a bad thing.
Yeah, so, you know, I've been having physics in my blood since I was born, and I even cut my teeth, literally, on the physics books of Enrico Fermi, who's one of the most famous physicists of the 20th century and was my dad's mentor. So one night we were invited to their house for dinner, and I was just a toddler. They let me loose, and I ended up chewing on his books. That was quite a scene. But he was a gracious guy, and he said a few nasty things in Italian that I won't repeat, and then he said, well, at least he has good taste.
The odds of accidental life seems extremely remote. Dr. Robert Piccioni has a PhD from Stanford and was formerly on the research faculty of Harvard. As a Bachelor of Science from Caltech, where he studied under famous physicist Richard Feynman, an expert on cosmology and Einstein's theories, Dr. Piccioni is developing a new TV series, Einstein for Everyone, and is the author of 2 books, Can Life Merely Be an Accident? And Everybody's Guide to Atoms. And would like to also add a special 25% discount on both books if when you order you mention Michael Vera or Blog Talk Radio. So everybody, please welcome Robert Piccioni.
Hi, Michael.
Good evening, sir. Hi, and how are you this evening?
I'm great, Michael. Thank you for having me.
Oh, thank you so much for coming on, and in such short notice, too. I really do appreciate that. I thought you'd be a really good fit for tonight and for this show, and I hope that we have you on a lot more in the future as well.
Well, I look